Good day, everyone. I'm Matt Pleil. I'm the PI for the Support Center for Microsystems Education. And today I'm going to give you a little overview on what we do with our hands-on professional development at UNM, but also that you can bring your students as well as part of our URE program. So I'll be speaking a little bit about who is the SCME and what we do, and a little bit more about the URE opportunity for your students, as well as other opportunities to consider so that you can get educated on micro nanotechnology and get resources to integrate them into your STEM classes. So what do? Well, we have educational materials. They're all downloadable from our website. You can also find them on the NanoHub website if you're familiar with that. We have asynchronous online short courses at scme.online. And we have hands-on kits available upon request, and you can see some pictures of that here. So we do professional development and outreach. We support faculty with clean room workshops, so the faculty can come out for a week and get an overview of clean room protocols, processing, how to make a micropressure sensor, and the associated educational materials that go along with that you can use in your classroom. Of course, we do conference workshops and webinars and one-to-one activities. If you want to chat about integrating certain things into your program, I'm always available for that. We do tours, fab tours. We're working on a virtual reality fab tour in the future. We collaborate with the NAC Center, which is at Penn State, and provide RAIN sessions, which is remote access instrumentation for nanotechnology. And we'll speak at STEM events, and I'll even talk to your students about micro nanotechnology. And as we mentioned before, we have the online asynchronous courses. We've created a community called MINTI-SIG. It stands for Micro Nanotech Education Special Interest Group. That's the organizing community that's putting this online conference together. We get a lot of help from our other centers, MNT centers such as MINTech, NAC, NEATech. We do online meetings every month. We have this annual conference, of course, and we have a website. So if you're not aware of the website, please go there and register on the front page, on the home page. And we have an industry mapping project where we map out the industries that are related to micro nanotechnology so you can see which companies are in your backyard that you may or may not be aware of. So this new opportunity that we're offering this year and next combines our traditional professional development for faculty with an undergraduate research experience for technician students. So you come with your students, and it's a really good opportunity. It's like a week-long field trip with your students. You get to know them better, and then you interface closely with my staff and myself during the week, and with our technicians and PhD students. So as I said, we target technician students and their instructors. Our primary partners right now are Pasadena, City College, Ivy Tech, Rio Salado, Lone Star College, but we're open to all tech faculty and students. Later this summer, we're going to have folks from Southern University at Shreveport coming out, 3 faculty and administrative personnel, to see what we're about and see how they can leverage it for their students. This summer, we'll have 22 community college students and educators participating in this program. And we've already done 2 groups, 1 week each. We give stipends out to both faculty and students, and that way they can afford to come and they don't have to come up with their own travel funding. So we generally recruit the community college technical education faculty and students in the fall time frame. We get them orientated with our online short courses and requirements, minimum requirements to come to the clean room. So we prepare everyone before they get here, because we want you guys to spend as much time as possible in the clean room and not in the classroom getting oriented. We can do that at our home site. And then once you're trained as as a educator, you can do a lot of that preparation yourself as part of a class perhaps. And the 1 week long session at our clean room could be perhaps given credit, a 1 hour lab credit for your students, since we're here about 40 hours, so that's typically what one lab credit is for most colleges. And then in the summer you come to the clean room. That's the building there that you would enter and participate in the hands-on activities. So there's lots of topics we cover, and we can cover depending on the interest of the faculty and the students. So we typically, for the 1 week courses or 1 week hands-on activities, we learn about photolithography, wet and dry etching, deposition, which includes sputter, evaporation, chemical vapor deposition. We do some electrical characterization, and then if there's time or interest, groups can split off and do different things, such as MEMS design principles or device applications. This last couple of weeks that we did this summer so far, we added microfluidics and microneedles. Dr. Nathan Jackson, my colleague in the mechanical engineering department, he is a bioengineer by training and has, I don't know, about a dozen years experience in making biomems devices. So he's our expert on these sorts of things. We also have another colleague, Danny Kiner, who's an expert on the micro-nano-bio DNA applications, and hopefully he'll be able to work with us next summer. And if the students are more interested in computer modeling or measurement systems, we do have several metrology tools that they can use. The key here, though, is they work shoulder to shoulder with the professors and the graduate students, and we all learn together and from each other, as well as with the technicians we have on staff. So the first thing we always do with newbies, as we call you, is an art wafer, and that's a lot of fun. So you learn the basics of photolithography and wet etching. You etch a silicon dioxide coated silicon wafer with a pattern of your choice. So you make a mask, and then you transfer that mask pattern onto the wafer and in photoresist, and then you etch what's exposed, and you end up with a really nice image. And you can do photographs and things like that. So we'll prep you on that. You'll provide us with the mask before you come. I'll get them printed out for you, so you don't have to mess with that. And then you'll make it. You'll make a wafer and get to take it home, show your family and friends, and get your colleagues interested in this opportunity as well. Once we go through the basic protocols and wearing personal protective equipment, making the art wafer, then we're ready to do the pressure sensor process. So we actually make a pressure sensor. And in the middle of the slide there, you can see a picture of the pressure sensor. It has a Wheatstone bridge on one side of the silicon nitride membrane, which flexes as a result of a difference in pressure from the top and the bottom of that system. You can also see in the inset the probes being attached to the Wheatstone bridge, and we can measure a change in output voltage as a function of how much stress the Wheatstone bridge piezo resistors are going through, which can be correlated to the difference in pressure. We have many deposition tools that we learn about. The primary ones we work with is the sputter tool. It can deposit a variety of metals and oxides, and but we also have a paralleling tool if we're interested in using that. That's to make devices biocompatible. There are also other uses for paralleling. Dr. Jackson's the expert on that. And then we have an oxide furnace for depositing oxide. We basically grow the oxide on the silicon wafers. These are our lithography tools, our main ones. We have a coat system where we coat the photoresist on there, and we have hot plates to drive out the solvent on the photoresist. We have an exposure tool. This is a 1X contact aligner made by Carl Seuss. It does front and backside alignment. We have a develop station, and we also have spin rinse dryers. And you'll find that out when you're here. We go through a bunch of chemical steps, and we always end up with a quick dump rinse and a spin rinse dry to get all the chemicals off of the system and stop the etching or stop the developing. We have a bunch of different etchers. The etchers shown here are the March Reactive Ion Etcher on the bottom left, and you'll be using that to etch the silicon nitride. And then we have an Alcatel Deep Reactive Ion Etcher on the right side, and that's to make very high aspect ratio and deep structures into the crystalline silicon. So you can see the result in the upper right or upper left, the etching results. So we make tall, skinny structures that go deep into the silicon, and you can see that there. This summer, some of the things we did is we got a field trip to HT Micro for one of the groups. Jared set that up with Todd Christensen, and HT Micro is in Albuquerque, and you can see the students there along with my PhD students and our two technicians, Mark and Richard. And as I said, we do the basic art wafer pressure sensor process. We also had time to do microneedles and microfluidics. We did some characterization work. One of the students did a deep dive into isotropic BOE wet etching. And then the equipment that the students got to actually learn how to operate are listed on the right side. One of the students spent an afternoon with Mark Hoffheinz, one of our technicians, to learn all about the 1X contact printer. He's actually has a poster on that project, so he took that information back to Rio Salado and is in the process of getting their contact printer up and running. And then next year we're going to have 2-week opportunities, so students can come for the first week and do the basic stuff, and then the second week delve into something in more detail. So they could, students and faculty can focus on, say, characterization, how to use a scanning electron microscope, go into detail on that, try different things, come up with some lesson plans. The students can measure and characterize various materials or devices or structures using that tool, and spend the week doing that and then writing up a research paper on it or poster. We can also have students do process optimization, so if they want to get better patterning results or try a different photoresist, they're welcome to try that, and I'll of course coach them along with our graduate students. And there's some biomems applications we can consider as well. We also will offer some design opportunities, so students can learn how to design in different masks, and you can see a mask set in the upper right. So I'm willing to pay for masks to try some different things. We can have multiple students do different designs on the same mask, and then when we can use one mask to do more than one design. Okay, so what are the next steps for you as faculty? Well, you can reach out to me. There's my email. Most of you know me already, so that shouldn't be an issue. We can chat about which weeks work for you and your students. So sometimes they can come early summer, sometimes in the middle of summer, sometimes late summer. We prefer the summer because we have more time to focus on that. But we might be able to do a 1-week session during our spring break or Christmas break. You'll have to review the online short courses. We can discuss which ones are required before you come out to New Mexico, and which ones are maybe optional but interesting for your students. And I'll collaborate with you on the online course requirements for the students. And then the stipends will be available for students and faculty. We usually break it up into 2 or 3 amounts, one before you come out so you can pay for the trip, and then one after you arrive to make sure that you come. And then sometimes we give a small stipend to the students that present a poster at the Minty SIG conference or High Tech conference, for example. And faculty generally get their stipends all at one time because we trust you to show up. Okay, additional opportunities. So please get involved with Minty-Sig. We're a fun group. You know, you can hang out and learn from us, and we'll learn from you, of course. You probably have a lot of things to offer to the community, and we'd love to share ideas and resources so to make all of our lives easier, and then that way we can move forward on new things that people haven't worked on yet. I need to acknowledge Dr. Jackson. He's been great at working with the students and getting them up to speed on microfluidics and microneedles. He has two PhD students, Pallavi Sharma and Rocio Vasquez, and I fund some of their work on the grant for us, so they act as TAs during our processing and work with the students. And they really enjoy doing this, so it's a lot of fun for them as well. And we're trying to train them up so that they can be really good teachers when they finish their PhDs, and if they go on to academia, or they'll have to train engineers and technicians in the future if they go into industry. So these are good skills for them to learn as well. And I really want to acknowledge my staff, Mark Hoffheinz and Richard Marchant. They're very experienced technicians. They worked at Intel and at Philips Semiconductors over the years, amongst other companies. They're also veterans. One's from the Navy, one's from the Air Force, and they still get along. So they're a good group of techs, and they love working with the students as well. So make sure you reach out to me. And we have a list of sources here. So we posted the slide deck, a PDF version of it, so you can go to this slide and click on all of those hot links there. So of course my email, our main website for the grant, our online short courses. You can join our collaboratory, the Minty-Sig group. Make sure if you're not a member to fill out the registration on that page. And then our key partner sites is MinTech, which is the national center that was just funded last year that Jared runs, and the NAC Center that Bob Ehrman is a manager of. That's nanoforme.org. And NanoHub has a ton of educational materials. It has all of our materials as well. It has the NAC materials on there, and also it has a lot of simulations and chemistry, physics, and all sorts of things on there. So you can go into as much detail as you want and go to as high a level as you want by investigating the NanoHub site. So of course, if you have questions, feel free to reach out to me anytime. You can send me an email. We can set up a Zoom meeting, and it'll be a lot of fun. And I can give you tours of our online resources and and that sort of thing, and talk a little bit more about the clean room. So I'm here to help mentor folks as well if they're going to start a course on micro-nanotech or microsystems fabrication. So I hope you enjoy the conference, or if this is after the conference, I hope you enjoyed the conference. Please watch the other presentations. There's a lot of good stuff.